The second story in this little book that I found, the Reader's Digest 1957 book of teenage stories. So interesting how to find things. Really crazy. See if I can get this. I don't think I can adjust it without breaking something, so we'll just leave it. There is a picture for this one. The newest evidence concerning the possibility of life on other planets. For thousands of years, men have looked up at the night into the stars blazing in the sky and have asked themselves, is there life in those remote places? Do beings like ourselves exist elsewhere in the universe? For centuries, it seemed that this question would remain forever unanswered and unanswerable. But now, astronomy has something to say about it, something that seems to me one of the most exciting of all the exciting things scientists are telling us nowadays. Among the outstanding authorities who have discussed this matter is the British astronomer Royal 64-year-old Sir Harold Spencer Jones in his fascinating book, Life on Other Worlds. Interesting that that's my last name too. The Earth, Sir Harold points out, is one of 9 planets circling a dwarf star of average brilliance called the Sun. The Sun and its planets are part of a galaxy of millions and millions of stars, all traveling through space at a high speed. Huge as it is 600 quadrillion miles in diameter. Our galaxy is only a speck in the known universe. Astronomers speculate that there may be as many as 1 billion other such galaxies. Sir Harold recognizes that life as it is known here on Earth is not possible on other nearby planets except within certain limited circumstances. Only a few simple organisms can exist long at temperatures as high as the boiling point of water or under 10 degrees below zero. The atmosphere must contain several things essential to life, like oxygen, and it must be free from lethal quantities of other substances like ammonia. On the other planets in our solar system, Mercury is far smaller, than the Earth, and therefore has a weaker gravitational pull. Thus, it has lost nearly all the atmosphere needed for life. Jupiter, Saturn, Uranus, and Neptune are much bigger than the Earth, and so they have held more atmosphere, including poisons which rule out life. Pluto is too cold. There remain Venus and Mars. What of them? The clouds on Venus might seem to argue the presence of water, but our best instruments can detect none. The clouds possibly consist of poisonous gases and dust. There's far more carbon dioxide on Venus than on Earth. Sir Harold says the temperature of Venus is almost certainly above the boiling point of water because of the strong greenhouse effect of the carbon dioxide. In consequence, the atmospheric circulation must be much more vigorous than on Earth. Cyclones, tornadoes, and gusty winds, much more violent than any we've ever experienced, must rage continually over her surface. Under such conditions, it's not likely that life could develop. On Mars, life is entirely possible. Mars is about 1.5 times farther from the Sun than it is from Earth. Each day is about the same as ours, 24 hours, 37.5 minutes. Its year, the time it takes to circle the sun, is almost twice as long. Mars has only half the diameter and 1/10 the weight of Earth, and because of its lesser pull of gravitation, the planet has lost some light elements that we retain, such as hydrogen and helium. The temperature would permit life. It ranges between 50 degrees above zero in the daytime to 80 or 90 degrees below at night. The climate is a great deal like that on top of Mount Everest. White caps around the north and south poles recede in summer and advance in winter. Great areas change color with the seasons, ranging from green to brown. Sir Harold says it's difficult to interpret these changes in other ways than by the seasonal growth of vegetation. As the ice cap melts, the moisture reaches low latitudes. The vegetation commences to grow, and the color of the area covered with plant growth changes to green. When winter comes on, the green color gradually gives way to brown. These facts suggest to Sir Harold that there is some form of primitive life on Mars, although the vegetation is apparently slowly dying out. He thinks it likely that there can be animal life, certainly no higher life resembling man, but this is of little importance compared with the evidence that life of some kind is not unique to the Earth. The fact that primitive plants grow in the thin Martian atmosphere suggests that life of higher sorts could arise and may have arisen elsewhere in the universe where conditions are better. Life doesn't occur because of some unique accident, says Sir Harold. It is the result of a definite process. Given the suitable conditions, these processes will inevitably lead to the development of life. Scientists are convinced that life on Earth began spontaneously, arising out of inorganic matter. It probably started in the sea 1 or 2 billion years ago. A.I. Oparin, the great Russian-born biochemist, has a fascinating theory of those earlier days. The Earth had been tremendously hot, and as it cooled, it produced carbides. These, in contact with the steaming atmosphere, produce the first of all organic substances, or hydrocarbons. Part of the hydrocarbons reacted with ammonia, forming various nitrogen derivatives. All of these were in the atmosphere and in the oceans as the Earth cooled in a hot chemical soup. Reacting with each other and with the water, they produced a huge number of organic chemical compounds, including the highly complex proteins. These big molecules clung together in droplets, endlessly forming and breaking, endlessly churning in the chemical-rich sea. Eventually, out of the trillions and trillions of droplets formed through the ages, some happened to be internally organized in such a way that they could attract chemicals they needed to maintain and reproduce themselves. It may have taken hundreds of millions of years for the appearance of the exact chemical combination which made only possible to show itself. A recent remarkable experiment has shown light on what may have been a step in this process. At the University of Chicago, chemist Stanley Miller put into a flask what are believed to have been the chief elements of the atmosphere 2 or 3 billion years ago: methane, ammonia, hydrogen, and water. He exposed them repeatedly to an electric spark. Within a week, he had produced 3 of the amino acids which are the basis of protein, the very stuff of life. So perhaps the first molecules necessary to life were formed by lightning acting on the Earth's atmosphere. In the study of what probably happened in those inconceivably far-off days, there is also an important clue in viruses, those tiny objects that cause such diseases as influenza, measles, polio, and mumps. Experts are unable to say whether viruses are living or dead, whether they are organisms or mere chemicals. The tobacco mosaic virus, for instance, can be kept in a test tube for years without food. It won't grow or reproduce there, but in short, it seems to be a chemical. But when it's removed from the test tube and placed on a tobacco leaf, it grows and reproduces like other living organisms. Nobel Prize winning Dr. Wendell M. Stanley of the Virus Laboratory of the University of California says that it's difficult, if not impossible, to place a sharp line separating living from non-living things when one considers a series of structures of gradually increasing complexity, such as hydrogen, water, benzene, egg albumin, insulin, vaccine virus, and bacteria. Work on the viruses has provided us with new reasons for considering that life as we know it does not come into existence suddenly, but is inherent in all matter. To answer the question, does life exist elsewhere in the planet, in the universe, we must first ask, how many planetary systems are there like ours? It's overwhelmingly probable, Sir Harold says, that many other stars have systems of planets like our sun. But to verify this theory is enormously difficult. The stars are so bright that we can't see dark bodies or planets that may exist near them. In fact, the existence of only one such planet has been mathematically suspected. There is a double star, two bodies rotating around each other, called 61 Cygni. And in 1942, Dr. K.A. Strand of the Sproul Observatory at Swarthmore College reported that one of the two stars had a small periodic deviation from its previous course. Dr. Strand calculated that this could probably be caused by an unseen planet with a mass 4,070 times that of the Earth. Another number. What do the laws of probability have to say about the possible number of planets where organic life may exist? Dr. Harlow Shapley of the Harvard University Observatory says that it's not unreasonable to suppose that one star in every million will have a family in every 1,000, will have a family of planets. Of these, one star family in every 1,000 might meet the conditions necessary for organic life. And of these again, 1 in 1,000 might develop highly organized, intelligent beings. In other words, the chance of another planet with sentient beings is only 1 in a trillion. There are thought to be, however, 100 quintillion stars. This could mean 100 million planets with beings somewhat resembling ourselves. The resemblance would, of course, be remote. There's so many variable factors involved in the mutation of 1,000 generations of any organism that the likelihood of the same course being followed twice is almost inconceivably small. Yet the experience of our own planet shows us how evolution moves over and over again from the simple to the complex. Desirable mutations make for survival, and intelligence is certainly among the desirable mutations. So, Sir Harold sums up, we cannot resist the conclusion that life, though rare, is scattered throughout the universe. It may be compared to a rare plant which can flourish only when the temperature, humidity, soil altitude, and amount of sunshine are favorable. Given the appropriate conditions, then, here, there, and everywhere the plant may be found. Some fundamentalists feel that the discussion of life on other worlds is in some way hostile to Orthodox religion, of course. Perhaps the best answer to them was given by Bernard de Fontenelle in his book, Les Pluralités du Monde, translated in 1688, where he wrote, "To think there may be more worlds than one is neither against reason or scripture. If God glorified himself in making one world, the more worlds he made, the greater must be his glory. Quite possibly, we may never be able to communicate directly with beings on other planets since distances are so fantastically great. But we can know, however, as we gaze up at the stars overhead, that science now backs up us when we say we are not alone."